So I'm Jarrett Cruger. I work at Nodejitsu as both like software and DevOps engineer. And I'm going to talk a little bit today about monitoring and how you can actually roll your own monitoring based off this like core abstraction in Node called streams. So a little overview. We're going to talk about like what is monitoring, metrics, then get into like streams as like this very, very useful core abstraction that like is a little hard to grok, but like with a little massaging, like it starts to make sense. And then like what does it do? And I'll go into a live demo where I will build from scratch, or ideally I will build from scratch a little like monitored like proxied HTTP server set. So monitoring metrics, like what is this, and like how do I do it? Like when you start building your application, like monitoring can be like a hard thing. Like, all right, what am I supposed to monitor? Like, what do I need to log? All these types of things like come up. Like you're just trying to build your application, you want it to work, whether it's like a little web application or just like you just want to help host your website. But like, say you might be doing something like not quite right, your site just crashes, and like, all right, where do you start to like discern the problems? So like, I like to think like simple monitoring is easy, in a sense, where this is the first thing you want to monitor, especially when you're using Node, is like memory is like your biggest throttle point. Like CPU usually completely fine, but if you're abusing memory and you're not like running on a server that has an extreme amount of memory, like if you're just like buffering everything into memory and not getting rid of it, like this can become a problem and just like crash your server. Start with logging. Like logging is, in my mind, like monitoring 1.0 is like just log everything. Like this can be like taxing on I/O if like you start getting a lot of requests, but I think the transparency and knowing what you're doing is worth it. And just basic alerts. Like any part of your program where like it could potentially crash. Like the old way to do this in Node is like process.uncaught_exception. If like something absolutely terrible happened with your application, like send yourself an email or like something. I think that's like the best place to start, because I see a lot of people running this problem where like their app like just crashes too many times, and then like something mysterious happens, and now it's like down, and they have no idea why. So like even when you're just like building a little basic like HTTP application, I think that's like your best place to start. So like, why is monitoring so important? Like logging being the first step, like that's I guess I've talked about logging. Scale. This is where like having more of a monitoring system becomes a better strategy. Is like now if you have more than one server that you're managing, like how do you get all of those logs that you were using for your basic monitoring in like one place? Intelligence guiding your alerts. So now like you had your processes that like, all right, if it crashed, send you an email. But like what if you didn't want to do that every time? What if there are certain areas that you recovered from? What if there are, I guess, what if there's like more data that you can gather from like when something goes wrong? Like this is where you want to start sending out more data and maybe make decisions based on that data. So like you want more data and metrics about your application, where like first one, like start with memory. Like if your memory gets over a certain percentage, like there might be something wrong with the server. Like there might be something wrong with your application. You want to be notified, maybe not like every time like memory spikes, but if it like hovers at a certain threshold for too long, that might be a better indicator of like what happens. And as I mentioned, you want to make decisions on this data that you're producing. Memory being like the first one, or you can make decisions on like response time. Like there are a lot of like different variables that you can start pulling out of your application. So, and like this is why it's so important, is that you want to avoid the case of human monitoring, especially by your users. I unfortunately had to deal with some of this where like you never want to be the guy that's like, hey, like your thing that I depend on like is not working. And I had to be that guy the other day, because like in order to run a full replica, like we rely on like NPM to have a database that we replicate from, or like one of their databases to be up to date, so that we can create our own database from like the metadata. And I had to be that guy the other day. And I hate being that guy, where it's like, why is this not working, or like why is it not, I guess, working as it should? So you don't want that. And so like talk about monitoring. The first thing I guess this is the second thing I like hooked up monitoring to, is that like the old NPM architecture, we depended on just like replicating a bunch of couches together and making sure they stayed like consistent. And we're making sure the replication was always up and running. That was the big thing. And because like CouchDB has this bug that there's now a patch for, that because when you're replicating a bunch of binary data, it can actually just get stuck. Where like Erlang has some crazy pattern matching like function that wasn't running efficient enough, and that would just be like, okay, didn't replicate, try and retry, and it would get stuck in this like infinite retry loop. And that would like allow things to like get out of sync. And the one way I figured out how to fix that is just completely kill replication and start it over again. So I had this this process that specifically monitored all that and handled the auto fixing. But there are cases where like it might not be able to fix it for whatever reason. Like if something terribly wrong happens, like you need to be notified. Or because I had this external process that just listened on changes feeds, it made it easier to, like, I was now monitoring externally, so that was handling most of the work. But if something wrong happened, like I needed to be notified. So this is where like custom events in monitoring become useful, where beyond just monitoring memory and be able to like do some math on your memory usage and make decisions on that, being able to define custom events can be very powerful. Because like now you have granular control over the type of monitoring you're doing on your application. So like for an example, like how I detected when when our replica was not defined is like I have a specific event where if I'm no longer getting changes from like a couch, and usually with how NPM works, there's always like a change at least every 10 minutes. Like if not more, because people are just like constantly publishing and updating modules, which is awesome. So if I'm not receiving any changes from that database, then that clearly indicates a problem. And also, like another big use case for like monitoring that I've dealt with is like inherently distributed architectures, where like we run this platform as a service at Nodejitsu. And in order to do like logging for like all of these like thousands of servers that we keep up and running, like that has to be done over the network, and that has to be like aggregated and like stored like somewhere. So the way we figured out how to do that is we now have what's called like a little agent or producer on everyone's server. So when you deploy your arbitrary JavaScript to Nodejitsu, you get wrapped in this this process called Forza. And what Forza does, it's like, hey, I got your application, I'm going to keep this up and running. And every time you like log your data out, I'm going to like send this as a little JSON packet like over TCP. And now we have these servers, these Godot servers, which I'll end up talking about, which then take that JSON packet and they're like, oh, I know this is a log from like this user, and now I can put this in a like particular I guess list in Redis, and also send this over PubSub. So now I can make decisions based on that data format I get. I can basically filter out a bunch of streams, split them, and just like send these separate streams all to different locations. And this is all done like very efficiently. So that's just like one example where this was necessary. I needed, in order for this to work, I needed to have like a middleman essentially in the mix that was like aggregating all the data and then putting it somewhere. I did not have control of the user's process, so I couldn't just like make sure that logging got sent to Loggly, or made sure that I guess like they were using some like other logging transport besides like the console. So that was the that was the solution there. So now I'm going to talk to you a little bit about streams. So by show of hands, like who here is very familiar with Node and has used streams at all? Okay, some of you. All right. So like, who here has like built like a little Express app? Something. Okay. All right, some more hands. So you've touched streams. You might not have used the actual streaming methods, but like every core, I guess, anything you're getting data from in Node, like whether it be a request or a response or like you can actually create a read stream from a file. Like these are all these like this stream abstraction. So like what does that even mean? So Node actually took streams from like the days of Unix, and like I always love showing this quote because the dude who wrote it is like the grandfather of streams. So read it. We should have some ways of connecting programs like garden hose. Screw in another segment when it becomes necessary to massage data in another way. This is the way of IO also. So like what he was describing is like in Unix, you have these commands like cat and grep. Like these are actually all like little streaming components where you can cat a file and now you can pipe that into grep, which then like acts as a filter. So now you can filter by an arbitrary regular expression or by like, some kind of like key of sorts. And that's really powerful. And like Node uses that very well. So can anybody tell me who actually said this quote? Anyone?
Dennis Ritchie?
No, actually it's this guy Doug McElroy. Who like, if you haven't heard of him, go look him up. He's a pretty cool dude. So like, this is where it came from. It's like it came from the early days of Unix. It allowed for like a very easy separation of concerns with like, I guess a common thing, which was like standard in and standard out. Like these were like two, I guess you could call them like file descriptors in a way, but like they were basically these two mechanisms that like, all right, if I just put data into standard in, send it through this program, if it can interpret that data, then you can like pipe it out and send it to another program. And like that was that piping connecting mechanism. And by utilizing this interface, it allows you to like optimize for like plugging things together. Where like the greatest thing about Node is that there are all these modules in npm, and if like I guess the more like anything that's dealing with data, if more of them are streams, now they become inherently more pluggable. Because like now this is this common interface that like works with the file system. It works with like a request. If I can start like sending data from any one of these like those pieces of Node into like any arbitrary stream to like do an operation, like that becomes really powerful. So here's like one example is in Node, like simple HTTP server. I already talked about like now you can talk to the file system, like both a request, a response, and this like read stream from the file system. They're all the same thing. They're all just like different flavors of streams. So what happens here is that every time a request is sent to this HTTP server, like it's like okay, like I need to send this piece of HTML down to the client. And what this var stream equals fs.createRead stream, what that's going to do is that it's going to start pulling the data from the file system bit by bit. And it's not going to wait for all that data to get aggregated into that stream variable. It's like, I mean, we're a stream. So what we can do now is like, I can just redirect that data right back to the response. So I'm just going to start like pulling this data out, and I'm just like, oh, okay, like I know this data is not flowing, so I'm just going to pipe this to this response. So that actually like optimizes for like your memory footprint. So like you will use the least amount of memory in this situation because you're not buffering all of that into memory. It's only going to buffer as much as it needs to internally. So you actually don't have to worry about that at all. So like that's an example of a particular type of stream, or I guess the request is a particular type of stream, like a readable stream. And along with that stream that I created from the file system, those are both readable streams. So how you can think about a readable stream is just a source of data that you either want to pull from or like just like send all the data out and like push it somewhere else. And there are a few different types of streams that are built into Node. There's like a writable stream, where the response in that particular case was a writable stream. Because now I can pipe to that, or I can just write chunks of data to it. and then maybe like then end that stream. Be like, okay, I've written all the data I needed to, and now it's done. A duplex stream, which is like kind of a weird thing to think about, is actually both a readable and writable stream. So the best example I have is like, think about like a telephone. When you're talking to somebody on the phone, like you're both like talking to them, like so you're writing information into the phone, and you're also listening. So you can like, that's like your brain is like reading information from them while still being able to write. So it's this two-way communication pathway. And then there's a special form of a duplex stream called transform streams, which is like what I'm gonna talk about a lot with how Godot works. So a transform stream is just a much simpler mechanism where you get data, you put it in this transform stream, and that's going to take each chunk, it's going to do some kind of operation to it to change it, and then keep passing it through. So you can think about, like, if you want to take a bunch of data, like say it's all like binary or all like string data, you can take that data, pipe it into a transform stream that will now, assuming that like, I guess that stream of like text data that was actually like, say it was JSON, but it was just like text form, you can actually turn that into JavaScript objects by just piping it into a stream. So we'll go over some like specific stream properties, where now like with the introduction of streams 2, we have this internal buffering I'll take in 4 of us. So like earlier in Node, like back in like 06, 04, you actually didn't have that. Where as soon as you receive a request from the server, if you tried to do some like async operation, like look up some auth, you could actually lose data. So if like somebody was doing like a post or a put request, like those data events just started firing off, and you actually had to manage that buffering yourself. And that ended up being like, that was a little complex for people to handle, and like, because like you don't expect that. So now we actually have this internal buffering, and that's where this high watermark comes in. Where if you're creating a stream like yourself, or like I guess writing a stream, you can set this high watermark value to be like anything you want. And this just dictates how much data should be buffered like internally. So like say you set the high watermark to infinity, and you just like pipe a bunch of data to a stream, you can actually run into that same like memory problem. Because if you don't have that stream that's buffering all that data, if you don't actually keep sending that somewhere, you can still like run your machine out of memory and have that exact problem. And one thing that became popular in Node around this stream abstraction was creating object streams. So internally, Node just deals with text and binary streams. So it's just, you're getting data from the file system. That's all either UTF-8, that's all just binary data. You can convert it to hex, but it's just all these string-based like formats. Now, like people in the user space, we're publishing models to NPM that were using these streams completely differently. Because like instead of on each data event just having like say, I don't know, 5 bytes of data, like what if you want to make sure that you're dealing with a whole object? So now like there's this mechanism where it's like, okay, I can just deal with like each time I get a data event, like I know that's going to be a complete JSON object that I can now do things with. And that's actually, I think, much more powerful, like when writing a user application in using streams, because like it's hard to think about like how would you transform like some binary data and actually like, I guess unless you're like writing a protocol or like I don't know, doing something of that nature, like what do you need to parse that binary data for? A lot of times we're just dealing with like JSON objects and maybe just like serializing that from like just string into JSON. So that's actually like a really powerful property. Now there's in 0.12 there's actually now a more formalized mechanism for like this flowing versus non-flowing, which is as I mentioned, like either using a data event, which like if you put a data listener on a stream, that's just going to start firing off data. And like what was introduced in stream 2 is this like non-flowing, where now you get a request. This data actually is paused by default. It's going to internally buffer that request data because like you don't want to lose any of it. And you can use it. You can use that stream data, or I guess get the data out of it. If you're not using this like magical pipe method, which I showed you before, you listen on this readable event. So what like readable describes is like, okay, tell me when this particular stream, say it's a request, I'm like posting you like a giant JSON object, and like I just want to know like when I'm going to get some chunks of that data. This readable event is fired as soon as like some of those chunks make it to that HTTP server. And now this introduces like a pull mechanism where I use this var chunk equals stream.read. This read function is like you pulling data out of the stream. Where I guess the opposite side of it, you add a data listener, that data is just being pushed at you. Like it's gonna like just give it to you as soon as you tell it to. So now like now that I'm here, like any questions regarding streams, because like this is like a core thing I want you all to understand.
How do you define, without parsing the data, how do you define when the data in the buffer there's enough so that you can parse the JSON object, for instance, or a line of a file or whatever?
So
I don't want to have to line a file.
Well, that's like a lot of times, like for any of these problems, somebody's already solved it for you. There are like some modules, one particularly like JSONStream, where like what it does is like as soon as you're getting data, you can attempt a JSON parse. So this module is like made by like a former engineer of ours, like where it parses line delimited JSON. So it's going to get a bunch of data. It's going to try and do a JSON parse. If that fails, then it's going to wait for more data and then just like buffer as much as like it's gotten at that point. And then as soon as that JSON parse succeeds, then now I can take that object and then push it to the internal buffer of the stream. Because now, like in that case, he made an object stream that then takes binary data and then is now converting those into just objects. So that's like a specific example of a transform stream where I actually use it in Godot, where I just take a bunch of binary string-based data that's coming over TCP, and now I get JSON objects, like much more useful to deal with.
So I have a similar question. It's about object mode and the non-flowing stream. If you enable object mode, does every chunk that you read come back as an actual parsable object?
Yes. Yeah. So that does happen. So if that stream is an object stream, like there's actually an argument you can pass to read. So for the case of like you're dealing with like binary or text data, you can pass like how many bytes you want to read from it. But like that's actually just not applicable if it's object mode, because it will automatically just give you one object.
Do you know how it does that? Like what the internals of object mode are?
It basically detects, well, like when you declare it as object mode, so now it knows that like you're like each push event, like each push onto that internal array will always be an object. So like it just makes those decisions. It's not trying to like parse anything for you or set it to a particular encoding. Like
so it's using an array instead of a buffer. Is that what's happening?
Well, like actually that's how it's I guess it's done underneath, is even with text data. Like I mean, array is just ends up being like a buffer if you're just like appending a bunch of like buffers to it. Now it's like you just have an array of like these like concatenated buffers. And in the case of object mode, now you just have like an array of objects. And that's how it looks internally. Okay, so now actually I want to go into, I'll try and elaborate on this, and we're going to write a little example. Well, we'll write a little HTTP server and dealing with some streams. All right, is this big enough? I want to make sure everybody can see. We good? Okay, cool. All right, so let's start out. We'll require some HTTP. Require we're going to talk about file system, so we'll do some of that as well. And that's it for now. Actually, I'll require a stream just in case. I might want to do something with this. And I'll allow the port to be defined on the CLI, just in case I want to like extend this. So I'm just going to slice the first two arguments off the array and assume that that first index will be the port, or I'll default to 80. Sure. So now let's create our HTTP server. So HTTP server, give it a function. Res. So we like to deal with some requests and responses, and let's just do some like basic like route checking. Where so if the rec.url equals this the root, we're going to do like the most basic thing. So we're going to do is that right head. So this this just establishes that like okay, it's 200, like we're cool. And we're going to just like write hello Node.js meetup. Let's see. Sure. And we'll end it with just to be nice. Slash. That's terrible. There we go. And return. So, somebody did this correctly. Oh wow. I got a bunch of new process going. There we go. So now I curl this localhost 8080. There we go. I just wrote some data to that stream. Where like if you're used to like using something like Express or like any of these frameworks, they actually give you some like nicer, I guess, methods where it kind of like hides the fact that this is the stream underneath. Where you got your res.send, or like some have like a res.json, so that you can just pass a JavaScript object. But in this case, like since I just wrote a string, it defaults to either taking like a buffer or like a string object, and it'll just like return that down. So now let's actually do some like more fun things. So I'm gonna write this little text file, and we'll actually do the same thing. Hello Node.js meetup NYC. So now this is in a file. So now we go back to this HTTP server. We're going to delete all that, and now we're going to use this pipe method, kind of like in that same example I showed you before. We can now create a read stream from this plain.txt file, which will, every time that request hits that root URL, like it's gonna I'll be like, oh yeah, grab this, gather it bit by bit, and now just redirect it back to that response. So now I'm not dealing with any writes in the end. It's just gonna give me whatever I have in that plain.txt file. Whoop. I actually put that plain.txt file in the wrong place. Damn you, terminal. There we go. There we go. So now we're just like, instead of just writing that text blatantly to that response stream, now we're pulling that from the file system and then redirecting that into the response. That's just like super basic like stream usage, like using the HTTP server. Now we'll do something like a little bit more interesting. So now we're gonna make this a new route. It's called random. And what this is gonna do is it's gonna take a stream of what's dev/u random from the file system, which is actually just like an unlimited stream of random information that like your operating system will give you. And I actually don't want it to be all binary data, because it's just going to absolutely destroy my terminal. Because I think the Mac terminal is also terrible at this. Like if you pipe a bunch of like binary data std out, like it just hates you. Like it's just like completely like, I think it might destroy just my tmux. But yeah, it's awful. So I actually want to create, I don't want to just do this. So I actually want to create a transform stream. So we're gonna create a little function here that's gonna return a transform stream. So this random transform, if I can type it. What we're gonna do here, so transform equals new stream dot transform. So now, when it comes to implementing streams, Streams 2 added some of these niceties where you only, like for a specific transform stream, you only have to implement one method. And that method is the underscore transform method. And that takes, like, you get a chunk of data, you get whatever the encoding of that data is, and you get a callback. Because these actually can be asynchronous. So in this case, okay, I don't want to like murder myself with all this binary data. So like let's turn it into something that is actually like readable. So I'm just going to do a toString to hex. So now like it should be like slightly nicer to me, and I'm going to push this to that internal buffer. And just call it callback. So now, that's the only function I need to define. And now I can just return this transform stream. No, I got stream.
I think might have re-entered the variable.
We'll see. We'll see if it blows up on me. Oh wow, actually, totally still destroyed my terminal. Oh yeah, totally. Yeah, yeah, there we go. See, this is exactly why I didn't want to pipe binary data to my terminal. Now, yeah, exactly. That was what I did want to do. And now we can just pipe to this random transform, which will return that function, and now pipe to the response. So now we get some pipe chaining going on. Now, let's do the same thing. Now we just got like flowing hex data now. It's like, okay, now that's gonna like go for eternity. Now, say we want to do a bit of like throttling on that data. We can actually change the transform where like we can use this callback mechanism that we have. So we're gonna push the chunk to the internal buffer, but before returning, we're gonna do a set timeout for, let's say, how long? Set timeout on this callback, and we'll do like 2 seconds. Now you can see it's getting it in bursts. So like every time it puts data into that underscore transform function, it's going to be like, okay, convert that to hex, then wait 2 seconds, and now we can continue. So that's like just one example of like how you can just implement like a very simple transform stream. Like, I mean, the usefulness in this particular case is questionable, but like just to give you the idea. What's up? Well, yeah. So actually, what that set timeout will do is it will prevent like the next chunk from coming into that transform. So it's going to wait until that callback completes before now that data can be grabbed out of that transform stream. So the pipe, magically takes care of it for us, but to make it more clear, that readable event wouldn't be called until after that callback has been executed. So by putting that set timeout, it's preventing you from being told that oh yeah, you can totally read from me now.
But I think what he was asking is your read streams buffer filling up since you're not pausing it?
Up to the buffer limit, right?
Yes, up to the default buffer limit. Yep. Yeah, that's the beautiful part about pipe is that now we have all this internal buffering, it actually handles that back pressure for us. Where like before, it was actually like kind of like crazy. You had to implement like your own back pressure, like our HTTP proxy module. You had to like specifically emit drain events like at the correct time to make sure that like the data coming in from the request was then like flushed into that next request. Like it's like painful to try and like wrap your mind around and like be like, how is this all working? So now it's like much easier and like simpler. Okay, so that's like basic little HTTP. Now let's get into like, what is Godot? So Godot is like the module that is the building block for building like a monitoring system. And like this is what we use internally at Nodejitsu. And like actually, before I get into that, the reason this like this was written based off of a popular project called like Remon, where like Remon, written by this dude Afer, he is basically like this brilliant like event processing system where you have all these stream-like things. You basically have this particular data format that you're using, and Charlie, who originally wrote Godot, like basically took that and was like, I mean, since all of our infrastructure was all Node, and basically just took the concepts from Remon and just implemented it. Because like Node has these stream things, like it's the same type of properties that were being used in Remon. So it was like very easy to translate over. It made like the actual maintenance or like upkeep of a piece of software like everyone at our company is very fluent in JavaScript. So now like we're not trying to like rock closure and like dealing with the JVM at all. So now we just have like this same thing written in Node. So like the data format is based on, it's like, all right, you get a host, like you can create like a service, and these are just all like arbitrary keys to define like a message that would be coming from a networked system. So like one of your boxes, it's running a particular web application. It's got what's its host, like usually an internal IP address of sorts. Like for example, we have like some internal IP address, like the service. The service kind of describes like what type of message it is. It's useful for like how you do filtering on the data. So in this case, like this is just memory. State, we're cruising, we're going good. Use Unix timestamp. Some kind of description. You can add arbitrary tags to your data, which can be useful for just like indexing if you're like sending it off somewhere, and like whatever the metric. So in this case, like 1024. So like your application is using a gig of data. Like wow, like I don't know what you're doing, but like that's kind of scary. So there are a couple, I guess, components of Godot, where Godot is this event processing thing, right? We like to think of like, I guess, when there are two sides to an equation, I guess in like dealing with web stuff, we have like a client and a server, where the client in most cases for like, you're writing an HTTP application. You have like the browser is a client, or like in my examples, like curl was the client, and the server was my HTTP server. So how you can think about Godot is that it has the same client-server relationship, except where you put the Godot client would be on your actual HTTP server. Whether it's like creating logs for you, or like whether you're sending logs in this specific JSON format, or like memory metrics, that's where it would live. And then you create another server that is then like interpreting like those messages that you're sending. So like reactors. Reactors is like the component which are actually just transform streams, or like kind of. But this is the component that lives on the server and then interprets the type of data that you're sending. So like really it's like a transform stream generator of sorts. Not the JavaScript generators, but factory. Yeah, the factory just has like terrible connotations, so avoid it. But yeah, that's essentially what it is. So in this example, we require Godot, and then we create this reactor, which is a function that the first argument of it is always the source data. So this socket is kind of the representation of the TCP socket that you're getting, except you can now assume you're dealing with all JavaScript objects. so that like that data format I showed you like up here, if I had like an onData event on that socket, each one of those data events would be a message that looks like that. So in this particular case, I get this socket and I'm doing a particular filter. Where like Godot has these particular transform streams like built into it. So this where is a filter essentially. So where there's a service where it's like health/heartbeat of any other, I guess, and then like that star is interpreted as like regular expression. It could be anything. So every time there's a heartbeat, let's send it to this expire reactor. And every time it gets an event in that expire reactor, it's going to like reset the state, where it's like, okay, everything is fine. But if it doesn't get a heartbeat message within like 60 seconds, then it's actually going to push a data event to that next reactor, which is going to trigger an email out to like whoever's your DevOps. So that's like a very simple, like arbitrary example of like how you connect up these streams. Your question?
So the US now is using service provider.
Yeah, so the email reactor, like how that works currently is that it basically assumes that you pass it some kind of auth or some kind of like email client library. We kind of default to using SendGrid. So you'd actually need some more properties in there in order for it to actually send a message.
Yeah, that's in your package and
Yep. Yeah, so that's the default usage because that's like all we needed at Nodejitsu, where we just use like SendGrid, we pass it the auth, and it like just triggers the email, and by default it just has like the JSON blob as the content, and you can set up the body or the title like however you please, or the subject. So yeah, that's what a simple server is like, where you set up this pipe chain of just transform streams to then assess your data, and then you can send that data, like you basically make assessments on that data, and you could send it off to a database. You could trigger an email. You could do anything pretty much, like anything that can be done that takes like a piece of data, assesses that data, and then makes a decision on it, or changes that data in some way. Like all of that can be done using this core little stream abstraction. So the other side of it, like how do you get that data? Where I told you before, we have this agent called Forza, which is actually a producer. It's a producer. It's written in C because most of our users' applications are all written are all run on like 256 megabyte instances. So you need to be memory lean. But all it is a simple producer that creates JSON of that specific format. And we have one of those built into Godot. And in a sense, they are just readable streams. It's like a readable stream that just creates data on a particular interval that you get. That's what the default Godot.producer will do. And prefer you just continually produce data, otherwise I don't know what you'd be doing with that stream. If it just produce some data and then that was it. I guess kind of like a useless producer. But so here's an example where, okay, this is what the possibly other end of that heartbeat would look like. You have this little Godot process running on your server. It connects to the Godot server, and every interval, every 15-second interval, it's just firing off a message over TCP. And that's just a very simple way to just know that your server is always up, that whatever data center your server is hosted in didn't just go down, or you will now know that definitively. So here, an example of some producer modules. There aren't too many currently, but Godot producer and producer, those are just, I guess, the abstract forms of creating your own specific producer, where it allows you to pass a constructor, and you just or do some inheritance, and you can create a specific producer that produces whatever type of data you want in that format. And one that I wrote, memory producer, which the easiest way is I just pass a memory producer into as a Godot producer, and I usually give it a service. So for a lot of our private NPM product services, I just define it as whatever role that thing is. If it's a proxy, I just tell it that, and it'll just continually every interval you tell it. I think it has a default of 15 seconds or whatever as a TTL. it will just tell you like whatever the process is using memory-wise, it will just like send that up. It'll do a little calculation of percentage. And then there are these two external producers written by this kid Machi, where it'll monitor your Redis, give you some like metrics on like an external Redis server, and then send those off. Or like for if you run like hot proxy in front of like a bunch of your servers, you can monitor that as well. Okay, so enough of like the core concepts. I want to show you guys a little demo, and we'll see if I can actually live code this.
So I guess you got a bunch of C. My C programs that write the file socket. Writing comment that those other producers.
Yep.
So I wonder how the back pressure would work. Let's say like you Godot cannot handle the incoming events fast enough.
Well, then it'll just drop it. Like that's how it currently works, I believe.
So there's no back pressure to handle it, right? Because we'd have somehow have to make it.
Yeah. So I guess on the client, if the client can't send it to we actually have it like load balanced, where I have like there's n number of Godot servers that are, I guess you could think about as load balancers or proxies, except they're just TCP proxies, that then send data to like, I guess, m number of other like Godot servers. So it's like load balanced over all of these. So like the probability of that happening is decently low, but currently because I guess the back pressure would have to be handled by TCP, if anything. So if it can't connect to a server, like it'll actually just retry and connect again. So DNS will like give it a new IP, and it'll just start sending it to that.
I noticed that there you can set the protocol use UDP as well.
Yep. Yeah. You can do
both.
both.
Just fall on the floor if there's nothing missing.
Yeah. Exactly. It all depends like how much, I guess, how valuable the data you're sending, and like UDP is when you just want to you just fire off like it gets what it gets, and then. It's basically an easy way to wrap like sending UDP data or receiving UDP data, but then also being able to use it as a stream, since we just parse those UDP messages and then like push it onto like an actual stream, since UDP unfortunately isn't a stream. But all right, Matt, how am I doing on time?
10 minutes.
10 minutes? Okay. So because we only have 10 minutes, I'll actually just show you the code. Like that'll be easier. So make sure. All right. So the idea here. Actually, I'll show you the picture first. So this is the architecture of like what I would build. Where this is like a very simple scenario where, all right, you have an HTTP server. Say you want to scale that, or you want to set a proxy in front of it so that like when you deploy like a new one, say you want to update like a brand new server and throw that into the pool, like you don't have to there's no potential downtime. And because like we live in the world of virtual machines, and they're like we kind of want them on, I don't know, I like servers on like different virtual machines, so you can just like spin up a new one, tell a proxy that there's now this new server that you can send things to. And now that's the new server in the pool. And then you can like spin one down and do the same type of, I guess, change for the proxy to like take that out of the pool. So what I wrote was a simple proxy that did some monitoring on the requests that were sent to these HTTP servers. So let's take a look at the code. Okay. So. This being the proxy code, this is basically a simple HTTP server that on each request will like arbitrarily load balance over the two predefined servers that I have. Like they're both running on localhost and running on two different ports. And I will also create like a Godot client so that I can send any of the data that I'm producing. I can send along to another Godot server to process that and just deal with that. So that's just this is just some overhead of setting up a Godot client, listen on the error event, just so log that, I did something wrong, and then if the Godot server wasn't running, it'll tell me when it's trying attempting to reconnect, because Godot has built-in exponential backoff on reconnect. It's okay. So this is just the predefined HTTP proxy takes a object that has a target property, which you can either define as a host and a port, or you can define it as like just a URL string. And that's just going to send the data, or yeah, so that's just going to be used as an array where you're just going to, I'm going to like shift and unshift from, or shift and then push to that array to just like constantly load balance on the two servers that I start. And then so where I'm actually calculating the metrics here is on the start and end events of the proxy. It's going to tell me when the request begins, like so when the proxy receives the request, and then it's about to like, okay, now I'm going to like proxy to this other server. It's going to emit that start event then, and then whenever that is completely finished, it will tell me when it's done. So that'll give me like a sense of how long did it take to process that request. So you can think about it like, oh, like how long does it take to, like for a particular route of my HTTP server, like how long does that take to proxy? So in this case, I'm just doing like, I guess the arbitrary like whatever route you're hitting, it's just gonna like calculate that and then send the response time off. So it produces the start event, produces the end event, and then just does a little computation like how long did that take? And then here's the simple server where I just shift the target off, proxy to that target, and then like push it back to the array. And then we can look at the HTTP server is pretty much the same thing that we built on before, except I added an automatic end to this like unending stream usually. And then I added some logging for when you hit a particular route. So now I will produce a message when we hit the root URL and when I hit the random URL. And it's just like some messy like JSON like logging. So that's the simple stuff. But like the more interesting part is like what does the Godot server look like? What am I processing? So we have two reactors in this case. One reactor, you're just dealing with any arbitrary logs that are coming through, and then just like consoling them. You can think of that Godot.console in reality would be like a logly stream, where you just like send that off to logly, or send that into Redis, like wherever you want to store your logs, Logstash. The reason I actually use this internally in Nodejitsu is because a lot of our logging is done on proxies. And like the normal way you actually like put things into Logly or into like one of these other services is like over HTTP. So what I would be doing is like, okay, I have this proxy which is handling a lot of requests, and then I'd be like wasting a bunch of sockets just trying to send logs over HTTP to just put them somewhere. So that's the reason where Godot is very useful for logs in our case, because now I only have one TCP socket on each of these proxies that's just like pushing data through. So it's not like abusing the sockets that are actually very valuable for proxying requests. So all that can just be piped through over one single TCP socket. And then same thing with any of the metrics data. So in this case, we're looking at like, okay, where I get a response time event, we're going to actually use this, and then we use this special stream. So we're going to filter by response time, and then use this special by stream. And you can think of the by is like a fork. So now I'm going to split this stream where I'm actually like duplicating data technically. So I'm getting this single source of data, and I'm splitting by host because I want two separate streams to do like different assessments on. So by splitting by host, well actually no, it's actually not duplicating data, I lied. It's actually just doing a filter based on each different host that I get, that's going to go to a different stream. So in this case, I'll just show you. Okay, so let's start the Godot server. We'll start HTTP on 8081 and 8080, and then we'll start the proxy. So now, proxy is running on like 4,000, So now I send a request. It's like, okay, I actually received 400. So that means that one of these servers isn't running properly. Of course. So it actually should be running properly, but it's still getting the metrics anyway. So what's actually happening here is it's actually correctly proxying. Oh, actually, I was looking at the timestamp. It's not 400. Oh, terrible. So on the right side, you can now see that I'm logging out the response time of each request. And each of those is actually calculating a mean of the response time. So for each request, it'll adjust the mean. And each of those is actually going to happen independently of each host. So to make this more clear, like, okay, this took 3 milliseconds to respond on localhost 8080. And that changed the average of the response time of the particular response time average for localhost 8080. It changed that to 2197. So now I do this again. Now you can see that it's a completely separate average. So what the by stream allowed me to do is, like, I'm now doing the same exact stream logic on 2 separate streams. Like, that by stream just allowed me to, like, I guess, have an easy way to compose, like, or to do that same operation for those 2 different hosts, or which could be like n number of hosts. So, like, this is actually exactly how I handle logging in our public infrastructure. Is I'm able to take, like, okay, I can split by each host, and then I can also split by each, like, user. So, like, I add that to the service. So that allows me to create a completely separate stream that's like forked, where, like, an app could have like three drones. So I split by user, and then I can have just a like one single stream of, like, all of that person's logs, and then send that into Redis, like on a particular key, which is like their username, app name, or like whatever it would be. So that's just like an example of showing the powerful, like, stream composition you can do using Godot, and just use any arbitrary stream to, like, store data. And that's it. That's all I got. Questions?
So besides the existing users and reactions that have been made, how many or are there any benefits to ZeroQ or Axon?
So I guess, like, ZeroQ and Axon, I guess they're more like powerful queues. Where I guess, like, Godot could be considered like a very, very lightweight queue, because I mean, it's just you're sending, like, data packets over TCP. So I consider Godot, I guess, a simpler, I guess, faster alternative, where the value, or I guess the determinism of your data, because, like, I have no internal, like, buffering or queuing built into this currently. So Godot by itself is just going to try and write to a socket, and if that fails to write, that data is lost. But, like, there could be a buffering layer where it's like, okay, I can put this into an array and then, like, try and write to the socket. If that fails, then, like, I still have to try again. So by building in a layer like that, then it could be used as a queue-like thing. But the power, I think, is just in being able to compose streams in order to like, make decisions and, like, do, like, calculations.
It sounds like ZeroQ would be possibly on a transport that you could add in addition to TCP or UDP, and then the power is this API that you have for, like, doing this almost business logic for logging.
Yeah, it's like doing this separate set of logging to be able to, like, filter out what data I care about, and then maybe, like, put that in a queue, like put that in a ZeroQ, I guess, queue system to then be, like, processed.
So these stream composition functions, right, are they published in separate modules, so I can use them outside of Godot?
I mean, that's actually something I thought about. Like, they could be.
Like the by one, right? I mean, this
Yeah.
is a stream by criteria. Like,
Yeah.
passing a function as a criteria or something?
Yeah, so I mean that's something I'd actually consider because I do like that by stream. So like my one plan is that these are actually still all streams streams technically. So when I go and like refactor that to use like the newer API, when like we have streams 3 and like there should be no overhead of using that like the simpler API, that's actually something I'll probably do, especially for like that one, like the more valuable streams that like you don't like I guess find anywhere else. We can do that. Anyone else? Questions, concerns, anything? All right. Well. Thank you all for having me. What?
One more. Publish the demo. The GitHub is 404 not found.
Yeah. I'll open source the demo now that it's done. So you will be able to see it. But yeah. So again, like I'm Jarrett Cruger, and you can check out my GitHub, Twitter. It's all the same. But thank you very much.